Welcome to SRA 221. In this quick lecture, we will discuss public key cryptography. Public key cryptography refers to a method of encryption, i.e. garbling a message so that unintended people cannot read it, in which for each person a pair of keys, digital codes, are involved. One called the public key, which is disseminated widely, and one called the private key, which is known only to the intended recipient. Any person can encrypt a message for a specific person, say Alice using Alice's public key, which is known to everyone. However, this message can now be decrypted only through Alice's private key. Thus, a message intended for Alice can be encrypted and safely hosted in public servers without an unintended recipient being able to read it. This system of using two different paired keys is called an asymmetric key encryption algorithm. Now, let's take a look at an analogy displayed here. Suppose that we have a lock, and this lock needs two keys in order to be used. A locking key and an unlocking key, and the two keys are distinct. So what we can do is put the lock and the locking key in the public domain. In a post office, anyone who wants to send me a message can buy a strong box, put the message inside the box, and then use the locking key, which is given to lock the letter inside. With that information, the sender can now send the locked box. I have the unlocking key, and I can open the box and retrieve the message. So now let's apply this to a real-world scenario. Suppose that Bob wants to use his credit card to buy some brownies from Alice over the internet. Because we are talking about PKI, what you are actually seeing here is that Alice has two keys associated with her identity, a private key and a public key. The private key is the key that only she knows and uses to decrypt or encrypt messages. The public key is the key that everyone else knows. So all Bob can do is receive the public key from Alice. Alice was in the public key to Bob so that he will now hold the key. With this public key, he will encrypt the credit card number and then send it to Alice. Now what is important here is that Alice has the corresponding secret key or private key. When she receives the message, she can use the private key to decrypt the message. Note that although the message travels on the web, nobody can actually decrypt the message but Alice, because Alice is the one that has the corresponding private key or unlocking key.